Big questions still remain about 3I Atlas. Now, a lawmaker is pressing NASA for new images of the space phenomenon, and could it also have a traveling companion?
The James Webb Telescope just spotted something terrifying happening with 3I/ATLAS, this ancient interstellar wanderer that basically drifted into our solar system like it had secrets to spill.
But this one, 3I Atlas, is really interesting. It's what's called an interstellar comet. That means it actually came to our solar system from another star system. So this comet was not born around the sun. It was born elsewhere. It's been drifting through space on its own, and it just randomly encountered the solar system.
Webb's infrared instruments picked up evidence that this thing has been blasted by cosmic radiation for billions of years, to the point where its entire outer shell has transformed into a strange, irradiated crust. Could this rewrite what we think we know about how planets form? It's high time we found out. Kindly stick around till the very end, because every question we have is about to get answered. The interstellar origins of 3I/ATLAS. The discovery of 3I/ATLAS was described as one of those quiet moments in astronomy that suddenly shift into global excitement, the kind of moment when a simple dot of light on a telescope screen ends up rewriting entire chapters of cosmic history. Astronomers at the NASA-funded Atlas Survey Telescope in Rio Hurtado, Chile, reportedly spotted something odd on July 1st, 2025. Something moving just a little differently from the usual asteroids and comets drifting through local space. Researchers said the object behaved in a way that instantly raised curiosity, almost like a traveler who wandered into the wrong neighborhood and kept walking without slowing down. After the first sighting, scientists dug into old data and uncovered what they called pre-discovery observations from 3 different Atlas telescopes placed around the world, as well as additional images from the Zwicky Transient Facility at Palomar Observatory, reaching all the way back to June 14th. This extended timeline helped paint a clearer picture of the visitor's path and confirmed that the appearance on July 1st was not a fluke, but part of a much longer journey through the skies. Once the news spread, observatories across the planet turned their eyes toward the newcomer, including teams in Hawaii, Chile, and Australia, while space-based instruments such as the James Webb Telescope and the Hubble Space Telescope joined the effort. Observers described a sense of excitement, almost like a cosmic mystery unfolding in real time, prompting the question of how often a visitor from deep space casually sweeps past Earth without anyone noticing. Astronomers determined that 3I/ATLAS came from outside the solar system by studying its trajectory and speed with great precision. Experts explained that the object followed a hyperbolic orbit with an eccentricity of about 6.15, and such a value leaves zero doubt about an interstellar origin, since nothing created inside the solar system naturally reaches such an extreme orbital shape. The motion itself reportedly told a clear story. The object came in fast, traveled on a path that refused to curve into a closed orbit, and headed back out into darkness without any sign of slowing down. Scientists often describe hyperbolic objects as cosmic passers-by, visitors with no intention of staying, and this one behaved exactly as expected. Could any local comet or asteroid pull off a path like that? Astronomers said absolutely not. That single detail placed 3I/ATLAS in a tiny, elite group of recorded interstellar guests, with only 2 predecessors ever confirmed. The elongated one, Oumuamua, spotted in 2017, and the dusty, classic comet 2I Borisov, discovered in 2019. Considering the size of the galaxy and the endless number of drifting bodies traveling between stars, the rarity of confirmed interstellar objects made this discovery even more extraordinary. It raised the question of how many such visitors slip past unnoticed, never crossing a telescope's field of view. Researchers also explored where this ancient traveler might have come from. 3I Atlas approached the solar system from the direction of the constellation Sagittarius, a region tied closely to the center of the Milky Way. This detail opened a world of speculation. Could this visitor have begun its journey billions of years ago in a completely different star system near the galactic core? Some astronomers suggested that the object likely originated in the Milky Way's thick disk, a region filled with old stars and rich cosmic history. Studies of the object's velocity, trajectory, and possible formation environment pointed to a staggering age estimate of more than 7 billion years, making it potentially older than the solar system itself. This raised more questions. What kind of star once hosted this ancient wanderer? What kind of gravitational event flung it into open space with enough force to send it drifting for billions of years? The incredible speed of 3I-ATLAS hinted at a long, unbroken journey across interstellar space, carrying physical material shaped during an era when the Milky Way looked very different from the galaxy seen today. Astronomers explain that studying an object like this offers a rare chance to gather clues about chemical processes and cosmic conditions older than the Sun, older than Earth, and older than most of the worlds ever formed around familiar stars. Scientists spoke about this opportunity with a kind of awe, noting that every interstellar visitor acts like a messenger from a distant neighborhood of the galaxy, carrying secrets that could help answer questions about early star systems, ancient materials, and the chaotic events that shaped the universe billions of years before modern observers existed to witness them. Could a single comet, like 3I-ATLAS, reveal the building blocks of planets from another era entirely? Could its composition show what space was like long before the solar system ever formed? With every telescope pointing toward the mysterious object, the world held its breath. Researchers hoped, maybe even prayed, that somewhere within its icy, dusty body lay the answers everyone had been searching for. After all, this was no ordinary visitor. This was a traveler that might have crossed half the galaxy just to glide silently through our skies for a moment before slipping back into the deep, uncharted dark. And as each instrument captured new data, the suspense only grew thicker. Because what the James Webb Telescope just revealed isn't just surprising, it changes everything. Stay with me, because this next part is unbelievable. What the James Webb Telescope just revealed, scientists reportedly described how the James Webb Space Telescope delivered one of the most surprising comet observations in recent years, when the near-infrared spectrograph captured detailed data on the interstellar visitor known as 3I/ATLAS on August 6, 2025. According to the scientific teams involved, this moment changed everything, because the telescope spotted an unusually shaped coma dominated almost entirely by carbon dioxide, a discovery that immediately raised questions about the comet's origin and past journey. The spectral images, covering 0.6 to 5.3 micrometers, revealed that the ratio of carbon dioxide to water sat between 7.6 and 8.0, a value so extreme that several researchers pointed out it stood more than 4 sigma above what long-period or Jupiter family comets normally show. Many scientists wondered how an object wandering across interstellar space could carry such a chemical imbalance. Could the composition reflect an entirely different star system with chemistry nothing like the one surrounding Earth? As analysts dug deeper into the numbers, the situation grew even stranger. Water vapor usually dominates comet outgassing at this distance from the Sun, yet this object seemed to ignore that rule completely. Reports explained that the comet was releasing roughly 129 kilograms of carbon dioxide per second, but only about 6.6 kilograms of water during the same interval. That meant water output sat at only around 5% of the carbon dioxide flow, a ratio nearly 16 times more extreme than expected. Scientists proposed several explanations, including the possibility that heat failed to penetrate the nucleus deeply enough to reach buried water ice. Another idea focused on evaporative cooling, where rapidly escaping carbon dioxide absorbed so much heat from the surface that water sublimation would have been delayed. Observers asked whether such a cooling effect could operate so strongly that water barely escaped at all. What kind of comet behaves like that? More discoveries emerged as the Webb instruments continued scanning the coma. Carbon monoxide reportedly appeared at a rate of around 14 kilograms per second, giving a CO to water ratio of about 1.4, a value that did not fit neatly into existing comet categories. Traces of carbonyl sulfide also surfaced, along with water ice grains and dust particles, forming a complex mix that hinted at an unusually violent history of radiation exposure. Several researchers noted that this chemical cocktail suggests that the ices inside 3I/AT-LAS may have spent long periods in environments where intense radiation stripped away or transformed compounds in ways rarely seen in solar system comets. Could this interstellar object have formed close to a much brighter star or within a region blasted by high-energy particles? The evidence pushed scientists to think about planetary systems very different from the ones surrounding Earth. Even more puzzle pieces appeared when astronomers examined the metallic gases escaping from the nucleus. Observations from the Very Large Telescope revealed an unexpected pattern: unusually strong nickel emissions paired with surprisingly weak iron signatures. In most comets, nickel and iron appear in almost solar proportion, so this imbalance forced researchers to question whether different heating processes operated on the comet's surface. Reports stated that the nickel-to-iron ratio slowly drifted toward normal values as the comet moved closer to the Sun, suggesting that temperature changes triggered different release mechanisms for metallic compounds. Did this behavior point to unique formation chemistry, or did it reflect exotic interstellar conditions that shaped the comet long before it entered the solar system? Conversations among researchers repeatedly circled back to the same idea. Every observation taken from 3I/AT-LAS seemed to contradict standard comet behavior. Experts described the comet as a rare opportunity to see what kinds of ices form around distant stars and what kind of chemical fingerprints interstellar environments can leave behind. Many asked whether unusual radiation levels, extreme temperatures, or even chaotic gravitational interactions in another star system carved the comet into something so chemically unbalanced that familiar models no longer applied. As data continued pouring in, scientists expressed excitement mixed with confusion, noting that each new discovery raised fresh questions instead of giving clear answers. Could an object so small carry secrets about how matter behaves in regions far beyond the reach of current spacecraft? The unusual combination of high carbon dioxide output, suppressed water vapor, unique gas mixtures, and shifting metallic ratios painted a picture of an object shaped by forces not normally found near Earth. Some scientists suggested that 3I/AT-LAS might provide clues about the earliest stages of planetary formation, while others wondered if it represented leftover fragments from a failed planet or a shattered icy moon in another star system. Whatever the case, the comet pushed researchers into a corner where old assumptions simply couldn't survive anymore. It forced them to slow down, step back, and admit something they weren't used to saying out loud: that the universe doesn't always follow the rules we confidently write in textbooks. Sometimes it behaves in ways that feel almost intentional, almost directed, almost unsettling. And the deeper they dug, the more this strange visitor from beyond our solar system challenged everything they thought they understood. What they uncovered next wasn't just surprising, it was genuinely disturbing. Now we step into the terrifying implications of the findings, and trust me, you'll want to stay with this till the very last detail. Terrifying implications of the findings. Scientists studying interstellar Comet 3I/AT-LAS reportedly described the object as one of the most unsettling visitors ever observed passing through the inner solar system. Researchers explained that the most alarming discovery involved the comet's heavily damaged outer shell, a surface that did not simply carry the marks of time, but carried the scars of billions of years spent drifting through harsh interstellar space. According to ongoing analysis, 3IATLAS may have traveled for nearly 7 billion years, wandering between stars while being battered by galactic cosmic rays that originated from supernova explosions and other violent events scattered across the galaxy. Observers explained that this relentless bombardment carved a radiation-altered layer estimated to reach at least 15 to 20 meters deep into the nucleus. The longer scientists studied this layer, the more they realized how fully the cosmic rays had transformed the original chemistry and structure. One researcher mentioned that the ice became increasingly compact over time as radiation kept breaking and remaking molecular bonds, leaving behind a crust that behaved very differently from anything normally seen on comets formed within the solar system. Could a journey this long reshape an object so completely that almost nothing recognizable remained? That question reportedly became one of the main points of discussion among comet specialists. Researchers explained that the original chemical identity of the comet's surface had been lost almost entirely. In fact, the outer layers no longer resembled the material that formed around the comet's birth star. This realization surprised scientists who had initially hoped that 3IATLAS might serve as a pristine sample of distant planetary systems. Instead, experts began to describe the comet as a natural laboratory that demonstrated how cosmic rays sculpt and transform matter over unimaginable stretches of time. Observers pointed out that this shift in understanding represented a major change in how interstellar objects are viewed. Instead of seeing 3IATLAS as a messenger from another star system, researchers now saw an ancient traveler carrying the chemical wounds of 7 billion years of exposure. Could anything survive such a cosmic journey without being changed beyond recognition? That question reportedly lingered during many scientific discussions. The more evidence scientists collected, the clearer it became that the outer shell held none of the comet's original characteristics. This led many experts to admit that 3I Atlas challenged long-held expectations about the value of interstellar visitors as untouched relics of their home systems. As 3I Atlas approached the Sun for its perihelion passage on October the 30th, the heat began to erode the irradiated crust. Scientists explained that they expected intense solar radiation to chip away at the outer layers, possibly revealing untouched core material buried deep within. Observers watched for any hint that such exposure might occur. If solar heating could remove enough crust, maybe the raw, ancient core could finally be sampled. Yet computer models suggested that the erosion remained far too shallow to reach anything pristine. According to researchers, ongoing outgassing only affected material already damaged by cosmic rays. Every particle of vapor released into space still came from within the radiation-processed zone. The unaltered interior remained hidden, shielded by many meters of compacted, altered material. Could the pristine heart of 3IATLAS remain locked away forever, unreachable even after a close solar pass? Many scientists believed that might be the case. The protected core, if it existed, stood as a silent record of a distant star system, sealed beneath a crust shaped by billions of years of cosmic violence. Researchers reportedly described this situation as both frustrating and awe-inspiring. On one hand, the inability to reach the original comet material limited what could be learned about the object's birth environment. On the other hand, the radiation-altered crust offered a rare window into how interstellar matter changes as it crosses the galaxy for unimaginable lengths of time. Scientists emphasized that no experiment on Earth could reproduce such extreme exposure over billions of years, making 3IATLAS a unique natural archive of cosmic ray chemistry. Could any laboratory hope to mimic 7 billion years of galactic punishment? Observers often repeated that it would be impossible. The comet thus became a once-in-a-lifetime opportunity for researchers to study how matter behaves in interstellar space, far from the protective influence of any star. Many experts observed that the radiation-damaged crust created more questions than answers. If this much transformation happened in the outer layers, what unknown chemistry might exist deep inside? Could untouched fragments of the original star system still be preserved in a hidden inner reservoir? Scientists stressed that only future interstellar missions might answer such questions. Until then, 3I Atlas stood as a reminder that interstellar objects carry long histories that may erase much of what once defined them. The idea that a comet could travel for 7 billion years and still arrive intact astonished researchers. How many events had this object witnessed as it crossed the darkness between stars? How many supernovae had bathed it in radiation? How many gravitational encounters had altered its path? The object reportedly seemed less like a simple comet and more like a survivor of cosmic time. In many scientific discussions, researchers described a sense of humility. Observers noted that 3I Atlas offered a lesson about the limits of human expectations. Sometimes interstellar objects might not provide answers about their origins. Sometimes they might only reveal what happens to matter when exposed to a universe full of radiation, chaos, and destructive beauty. The comet's damaged crust told a story of transformation rather than preservation. Experts suggested that this perspective could influence how future discoveries are interpreted. Could the next interstellar visitor also carry a history shaped more by the journey than the birthplace? Many researchers believed that possibility must now be taken seriously. Overall, scientists explained that 3IATLAS stands as one of the most altered interstellar bodies ever studied, shaped by forces that operated across billions of years. The erosion during its solar passage revealed just enough to confirm the depths of radiation damage, but not nearly enough to offer a glimpse of the untouched core. Observers agreed that the ancient nucleus remains a mystery sealed behind layers of compacted ice and cosmic ray chemistry. This combination of profound damage, incredible age, and continuous transformation left experts wondering what secrets still lie beneath the surface and whether humanity will ever develop the tools capable of uncovering them. With this, we have come to the end of this video. Thanks for watching. If you enjoyed this video, do well to like, comment, and subscribe for more content. To enjoy more thrilling stories, click now on the following video that pops up on your screen.